In this video, I'm going to show you how to rebuild a GT4088 turbo. This compressor wheel is the same as a T67 67x84, and this turbine is a special one. We actually do have these replacement turbines for that. For what happened to this turbo, it was run without oil, so the cage failed in it. And this is our new one. You have to reuse the original pin because I don't know if anyone makes a pin like that for this model. You can see where the oil galleries are for this, which is kind of interesting to see that, because the way this is designed is the oil feed goes through the pinhole and it's distributed to the cages, or each side of the cage. Before you take this apart, make sure that you mark the compressor wheel, the nut, and the shaft if you want to retain the original balance. If you plan on balancing it or having it balanced anyway, you need to, or you don't have to keep that orientation. So I'm going to show you first how to install the piston ring seal on the collar. These piston ring seals are the same as the Ford Power Stroke GT37 VAS and also the GT37 VA, or 3788 VA. You can also take the piston ring seal and insert it into the bearing housing to check to make sure that there is no gap there so that it's not worn. Once you insert this, you can tell that there is supposed to be a very minimal gap there, which will ensure that the oil will not pass the seal. If you have a larger gap than this, then it's likely that you need to replace your bearing housing. Just like I showed you with the bearing housing, you can also check the compressor plate to make sure that it is still good by putting the piston ring seal in it. In this case, I already did this before this video, so I'm not taking this back off. You can also install the piston ring seal on the turbine wheel. It's also a good idea to check to make sure that the gap here is correct on the sides, because these shafts can wear out like this way. If your shaft is worn on that groove area, it will definitely be obvious. Here's one that is brand new so you can see what it should look like. So oil your thrust collar and prepare to put it inside of the seal plate. You can now insert the bearing cage. Do keep in mind this is directional, and make sure that you pay attention to it, because it's very possible I bought one of these, somehow it was built or put together backwards. So this piece that sticks out goes towards the exhaust wheel, and that pin area sits right here, not over here. This is the flat piece, or the piece that doesn't stick out. So this goes down, and then we'll have to bring it back up and press the pin in. So I turned on the light so you could see this, but you'll have to line up the location of the cage and the bearing housing so that the pin will go in there properly. So it's a good idea, once you have it lined up, to squirt some oil down in there, and you go ahead and clean this pin, and then you can insert it. The way I do this is the oil feed I put between the two feeds on the cage, and we'll be using a 7mm socket to press this in, which I have here. So here's what it looks like when you have it pressed all the way in. One thing that you should pay attention to is make sure that these are always spinning as you're pressing it in. If these stop spinning, it's because you put pressure on this cage because the pin is not aligned properly and it needs to be pulled back out and reinserted. One trick that I learned just from messing with this stuff is that if it starts to, or you worry a little bit about it being off center, you can actually push this in and out and make sure that you get the alignment right, as long as it's good on the side to side. But that's really a last resort. So now you can insert this seal. And your front plate. There is a ding right here, but it doesn't have anything raising up on it, so it looks fine. This has no specific orientation, but on the Power Stroke it does have an orientation. So just keep note of that for if you ever rebuild a Power Stroke turbo. And go ahead and put some Loctite on these. These actually have a specific seal on them too. If you want to torque these down, that would be about 12 foot-pounds or so for that size bolt. Install your heat shield. You're going to need to have some type of tool that has a hole in it so you can press the shaft through. If you do this correctly, you should be able to spin the bearing housing. This will help the seal seat in properly. You can install the compressor wheel now. By the way, this is left-hand thread. So here are the 3 marks that I made that I have to align to restore the original balance. Or, if you had the turbo balanced, it should have, as a rotor assembly, it should already have these marks made by the person that balanced it. So here's with the alignment marks all aligned and the compressor nut is torqued. As long as the compressor nut, shaft, and compressor wheel are in alignment, that's the same torque spec that it was before you took it apart. Here's the finished product. By the way, if you see that crazy balancing, I didn't do that. That was actually how it was balanced before I took this apart. This right here is actually a precision version of this turbo. So if you thought this video was helpful, please like this video and leave me a comment. If you have any questions, you can always contact me at turbolabamerica@gmail.com. This is what the oil drain looked like after removing it. If you'll notice, well, you can't miss it. There's a lot of metal flake on that. That's shavings from the bearing cage coming apart. The most important thing to keep in mind is if you ever were to rebuild a turbo like this for a customer, these can wind up going through your oil siphon and back into the turbo if you're not careful. Some people don't know this, but above 4,500 RPM on some vehicles, the oil filter is actually bypassed so that it has enough oil to plumb the whole engine at higher RPM.